right, so we have some properties that go along with logarithms that should look real familiar to you because they're really the same properties that you've used in a way with exponents. The exponent rules and the log rules are very similar, you'll notice. So if you have a log of any base, and that's what the A is, don't let that distract you. It's just meaning whether it's base 10 logs, base 2 logs, whatever base you're talking about, the log rules say that if you multiply two values together, you could expand that to say it's the log of that base of x plus the log of that base of y. So multiply expands to add. You might remember with exponents, if you have 2 to the third times 2 to the fourth, we would add the exponents and call that 2 to the seventh. So this like base idea, like bases with exponents, when you multiply, you add. So this goes along with that. When you multiply, logs are exponents, right? So when you multiply, you add. And again, they have to have like bases. All right, so next one, again familiar to us. If you are dividing, divide, subtract. When you have like bases on logs, you subtract. So the log base A of x divided by y, divide, expands to subtract. Log of that base, notice like bases, of the x minus the y. Rule C, again, just like the exponents, if you have an exponent raised to an exponent, and a log is an exponent, raised to an additional exponent, that multiplies. So the R wraps around as a multiplier, an additional multiplier, right? R times log base A of x. So this stuff, the R comes down, multiplies onto that. Rule D, log of any base with the same argument will come out to be 1. And that's because anything to the first power will equal itself. If you have log base 5, 5 to the first will equal 5. Just by the way that you rearrange an exponent, this means the base, this means the power, equals that number. So any like things there is going to equal 1. The next rule, if you have any base raised to the 0, the answer will be 1. So if it's 5 to the 0, a base 5, 5 to the 0 is 1, anything to the 0 is 1. And then some also lesser used ones maybe. A base raised to a log of the same base of x, these cancel each other out, just the x. The log of a base, that same base raised to the x, these cancel each other out and just leaves the x. How you're going to use this on today's lesson is just get used to those rules. Kind of like the first time you learned your exponent rules, you just had to do a bunch of random problems practicing those rules. That's what you're doing here as well. And then in our last lesson on Monday, we will we'll solve equations with it. We'll use it more in application. But let me show you some of your homework problems and an example, if I can find one. Okay, so this is number 13 in your 4-3 homework. And it just wants us to practice expanding this with these rules that we've just learned. We know that this is times, so we'll change that to log base 3 of 8. And where it has times, we'll put plus log base 3 of y. And because that's divide, we'll say subtract log base 3 of z. So just knowing to expand, multiply is add, and divide is subtract. And that's all you do to that one. Okay, number 14. I think it'll be 15 and then 14. 15, we're going to go in the reverse order of what we just did. Notice they're all like base logs. So we've got log base b of m. And I'm going to condense it down to just one log, by the way. That's my goal, is to write it as condensed. You know, this one was condensed and they wanted us to expand. This time we're expanded and they want it condensed. So all log base b, so like bases, so we can write it as one log base b. M, because it's minus, that's divided by n. And another minus, it's also divided by u. So that's all we need to do to that, is just know that because these are both minus, they will wind up being divided. The m was positive, top starts it out. Okay, number 14 now. Okay, this time I'm generated out. One thing you need to remember to do this one is that the square root symbol means the 1/2 power. So we're going to write this as log base m of 2r to the 5th over z to the 7th, and all of that is raised to the 1/2 power. Okay, so if you have a radical, change your radical out to a power. Radical with square root is a 1/2 power. So by the first rule, or let's see, what is it, the third rule, if you have a log that has a power on it, that power will be a multiplier onto everything that we do. So all of these are raised to that power, so this is a major multiplier. 1/2 will be times log base m of all of this expansion. So this is times, so I'll say log base 2 plus log base m, I just drag it along, of r to the 5th. And then when it's divide, I say subtract log base m of z to the 7th. That is correct, but sometimes they go a step further and say also, by the way, I've got a 7 there. It's z to the 7th and r is to the 5th. So these are powers on those individual logs as well. These powers didn't apply to the whole thing like the half did. The half was a power on all of it, so it's a major multiplier. But this r is also to the 5th, so I could bring that 5 down and say that 5 is a multiplier on that individual log. So log base m of 2, the 5 multiplied on, would be 5 log base m of r, and this 7 is multiplied onto that individual log. And I think that's how your homework left it, but then another option would be the 1/2 then to be distributed in front of each of those terms. That would also be correct. I'm going to do it on time.
Oh, you've got 5 minutes left.
So I think that takes you through your homework on 4.3. There's a lot of using the rules and expanding and condensing, some practice going back and forth between exponential form and log form, and then some graphing. So let's go ahead and look at 4.4 now. We just pick some of your homework problems in the few minutes we've got left. Okay, so 4.4 starts out with a nice problem. It just says use your calculator. So we want to find our 2 log buttons on our calculator. It says find the log of 22. Now, if it doesn't say anything else in this little subscript, it's understood to be base 10. And that's what your calculator automatically knows is base 10. So when you hit log 22 equals on your calculator, it's saying 10 to what power is 22. And so it doesn't come out perfect. So it'll be an irrational number and a long decimal, but we'll round to whatever place it says. It says round to 4 decimal places. So go ahead and hit that in your calculator. Look at that. Okay, so I've got 1.342422681, but just one of those 4 decimal points places there. All right, so that means 10, base 10, raised to that power should equal 22. And you can check it out to verify that is what the calculator is calculating. Okay, number 2. Again, doing a log problem, and it's called the common log. Log of 0.0633. So again, it's assumed to be base 10. So I can just hit my log, regular log button. You know, I'm going to have to tell you what to do when they're not base 10 in just a minute, aren't I? Okay, to 4 decimal places. Number 3 says use your ln button. ln of 67. So you also have an ln button on your calculator. ln assumes base e, unless otherwise stated, base E. So it's saying E to what power is 67? E is a real-time value. It's 2.718 approximately, but your calculator is already programmed to do base E when you hit the ln button. So ln of 67 should be approximately 4.2047. All right, so what if it is not base E or base 10, like number 8? Number 8 says find log base 2 of 9. So you might have a calculator that has a little subscript button, but most calculators do not. Do not calculate anything but base 10 or E, just normally with the regular function button. So to do this, we're going to use the change of base rule, change of base theorem, which says if you take the log of base 9 of any base, so you can use your ln button or your log button, those are the two that we have access to easily, but it could be the log of any base of the argument divided by the log of the base, then that will ratio that out to tell you what the actual log answer is. 2 to what power is 9? We would expect it to be a little more than 3. So check that out on your calculator. It'll be the log of 9, close your parenthesis, or equal that out first, then divide by log of 2, and that's approximately 3.1699. And like I said, that means 2 to what power is 9, the meaning of your log problem. And then you have a couple of application problems. Just practice using your log buttons mainly. I think that pretty much covers it. So we'll